Hi everyone. Let's do some review of 2.7 to 2.8. Let's go ahead and get started with given the graph of f, sketch the graph of f prime. So the key thing to remember here is that where f is increasing, we will see that f prime is positive. Where f is decreasing, we will see that f prime is negative. We'll also want to look for inflection points on f because that's going to have a relationship to something on f prime. And let's get into it and talk about it. You know that where f is concave down, so the whole time it's concave down, we know that f double prime is negative, right? And doesn't that mean that f prime would be decreasing, right? F decreasing, f prime less than 0, that would mean f prime decreasing, f double prime less than 0. So that's that connection right there. So now let's look here where f is concave up. That would mean that f double prime is greater than 0. F double prime greater than 0 would mean f prime is increasing. So this inflection point is happening right here. That's an inflection point on f. That's where f is changing concavity. In other words, where f prime is changing from decreasing to increasing. If f prime was going from decreasing to increasing, isn't that a min? So inflection points on f are probably going to look like mins and maxes on f prime. So those are the main things that we want to be looking for, and let's see how we get into graphing that. I'm going to go ahead and just erase those highlights for a moment, but I'm going to keep my inflection point. I have another inflection point around here, don't I? Isn't that it? Concave down, concave up, concave down. Now, I personally like to start with the increasing and decreasing regions. So let's start with f increasing. I see that f is increasing from here to here, from here to here. So those are going to be positives on f prime. Positive, positive. My zeros on f prime, let's mark those. That's a 0, it's flat, and a 0 here. Now f prime is negative where f is decreasing. Negative, negative. And now it's just a game of connect the dots. Remembering that at our inflection points, we are going to have mins and maxes on f prime. So I'm going to draw my final answer in red. So I should have a min around here, right? Because it's negative. And here is another min or max, but it's positive, so it should be a max. And for now, I do not care how much up or down you go. We will get into that when we get into chapter 5. For now, I just need to see a nice continuous curve without any special kinks in it because this graph doesn't signify that I should have any. So really just connect. You know, the positive is up here. Positive, connect the dots. Negative, positive, negative. Make sure that the inflection points are marked. Those are the things I'm going to be looking for. Another one, given the graph of f, sketch the graph of f prime. Let's do the same type of thing. So f was decreasing from here to here. Where else is it decreasing? From here to here. That means that f prime is going to be negative on those regions. Negative, negative, okay? Now, let's mark our zeros. They're going to be here. It flattens out here, so it is going to be a 0 here also, and then a 0 here. In this one, it's going to go increasing, 0, increasing. So let's make sure that we mark all of that. We have positive, 0, and then positive again. So now we have to play a game of connect the dots. Let's also mark our inflection points. We were going from concave up around here. It looks like it's getting unhappy right around here. So that's going to be an inflection point. Now it was concave down and then it turns to concave up. So we actually have an inflection point and a 0 right there. And then it's happy, happy, happy. And then it looks like it's getting sad right around there. So then it's concave down for the rest. Okay. So now I have marked my zeros and I've marked my inflection points. Remember, our inflection points on f are going to be our maxes or our mins on f prime. So now let's see if we can play a game of connect the dots here. We're going to have negative, 0, positive, 0, positive, 0, negative. You see that? So negative, 0, positive, Now our max should be right around there. So let's make our max right around there. Come down. Now look, we need a 0 and then we need to jump back up. This one's not going to cross. It's going to touch, right? Because we went positive, 0, positive. Right there. And then our max should be right around there again. So boom. And then it's going 0, negative this time. Okay, just make sure it looks pretty smooth. And that's a pretty good answer. Now these are given the graph of f, sketch a graph of f prime. These were from your textbook problems. So we had increasing, and then for the rest of the time, we have decreasing, but it's getting closer to 0. That's something that we have to keep in mind. So we just have 1, 0 here. And then we had positive because it was increasing, and then we have negative because it's decreasing. But notice that it is getting less and less negative, and it's like zeroing out almost right there. You see that? So our derivative, this is f prime, should be getting really close to 0 at the end. And we have an inflection point around right there. So let's go ahead and make that our minimum in this case since it was negative. It was positive, 0, and then it comes up. If you go up here, no, that's not correct. It can't cross. We touch it, and then we're coming and we're flattening out because see these numbers, the slope is getting close to 0, but it doesn't quite hit 0. So it's just getting close to 0 there, kind of flattening out. That's the graph that we need for that one. Now in this next one, number 6, we have increasing, and then we have decreasing. But this graph has some more complexities going on. So let's mark it as we normally do. We have f prime is 0 there, and then our inflection points, and then increasing, so positive, then decreasing, so negative. But we cannot simply do this. No, that's not correct. Anyway, we knew we had this is positive, so a max, and this is negative, so a min. Mark those for a second. Okay, do you see what's happening at this tail? Right here, it looks again like our slope is almost 0. It's not quite 0, but it's close to 0. You see that? And right here, again, it's negative, but very close to 0. So that means at the edges, I must be coming up close to 0. So let me erase those marks. But that means at the edges, I must be getting close to 0. So this from the positive end, I'm getting close to 0. And this right here, from the negative end, I'm getting close to 0. All right, so now I kind of have to just hit all my marks. All right, kind of like that. And it should, since this is more symmetric, I should have more symmetry here. But again, I just want to see you kind of hit all of those marks of understanding that these are the inflection points, that it is getting close to 0 at the end because it's flattening, okay? Close to 0, but not touching 0, and that, you know, it's positive here, and negative here. That's really all I need to see from you. So now let's go ahead and go the other way around. So now they give you f prime, and let's sketch f. So this is f prime. I like to make my number lines, you know that. And my zeros in f prime are going to be at -1 and at 1 here. What did I see? I saw that f prime, I just want the sign chart. So where is it positive and negative? So it was negative, then it became positive this whole time, and then it becomes negative again, right? F prime negative to positive is a min, and positive to negative is a max. Those were my zeros, those were my zeros, and then I'm going to have a min. I'm just going to mark it off for a second right around here, and I'm going to have a max right around here. Okay. Now, I really could make another number line of f double prime because where f prime is decreasing, we know that f double prime is less than 0. Same thing, f prime increasing, f double prime greater than 0. And isn't that going to tell us something about the concavity of f? And also inflection points. Okay, so all of this is going to be told to us by the f double prime number line. So let's go ahead and make it. We see that f prime was decreasing from -2 to -1.5. It was decreasing. And then from -1.5 to 0, it was increasing. And then from 0 to +1.5, it was decreasing, meaning f double prime is negative. And then f prime was increasing until 2. So I'm just going to say f double prime is positive. I don't know that it's changing after that. So now I know that I have my inflection points on f wherever f double prime changes sign. And I also know that f is concave down, f is concave up, f is concave down, and then f is concave up again. So that's really going to help us with our drawing. I'm going to draw my f in black. So we are concave down until negative 1.5, until right there. So we have to start concave down. We also have to have a min here. Let's take advantage of this minimum. So we know it was concave up between negative 1.5 and 0. So it's happy between negative 1.5 and 0. Negative 1.5 and 0, it's happy. All right? Now make it a little bit unhappy right there, because it started concave down. So we see our inflection point, boom. Now let's make this thing happy. And then maybe right here at 0, right, we have another inflection point. So make it unhappy. I want to touch this maximum. We see it's concave down from 0 to 1.5. So right there, right? And then it's going to flip up and be a little bit happy. So right around 1.5, flip up and be a little bit happy. Just kind of like we did there. So I can see that inflection point there. I can see that inflection point right there. I can see my minimum right here, my maximum right there. And that's really what's important to me, is that I'm seeing that it flips concave down, concave up, then it was concave down, the next whole region here to here. And then it's got to flip up again at the end to be concave up. So that's really what I need to see from you. Mins, maxes, inflection points. That's really it, okay, for now. So this one was from your homework, and they originally gave you that this was the graph of f, right? And they said draw f prime going through f of 0 equals 0. So really that just means that I need to start here. So isn't this just look like the graph of y equals e to the x? And the antiderivative of y equals e to the x is just y equals e to the x plus some c. And so if I have to go through 0, 0, then I just shift it down a little bit and it's going to look like the same thing. I mean, anyway, you know that f is positive this whole time, and we're going backwards here, right? Because we're doing big F. So this is like the derivative. So we know big F must be increasing the entire time. And so that's just really what it looks like. You kind of just need to think about it in that way. And anyway, you know this looks like the graph of y equals e to the x. So that should make it a little bit easier for you. I want to just quickly touch on this relationship, which we talked about previously, the second derivative test, and kind of just show it to you more visually right now. This one is saying when the derivative is 0 and f double prime. Remember that this is notation for f double prime. So when f prime equals 0 and f double prime is greater than 0, then we know the point is a minimum. Really, f double prime greater than 0 means that f is concave up. So wherever f is concave up and the derivative is 0, we know we have a minimum. If f double prime is less than 0, you know that means that f is concave down. If f prime also equals 0 there, okay, so it's concave down and flattening out, then we know we have a maximum. Now, if it flattens out and it's not concave down or concave up, actually it's changing from concave down to concave up, then f double prime would be equal to 0. Okay, so that's actually an inflection point because we're changing from concave down to concave up there on f. So that is an inflection point. So I just wanted you to visually see that second derivative test, make that connection between the two chapters. When given the graph of f and asked to sketch f prime, how do we know how much up or down in the drawing we should be going? We are going to be getting much more into this as we get into chapter 5. So for right now, I just need those major things of the inflection points, the mins and the maxes pointed out as I've been talking about. But I do want you to see this little activity here. So basically, remember that when we're drawing f prime, what we're drawing is the slope of the tangent line at that point. So here, for example, you know it's 0, right? So you can see that I'm drawing a 0 on f prime. The green is f prime being drawn. this red line is just the slope of the tangent line, and that's pretty much the y coordinate of f prime, right? So if we were over here, you can see that, the slope right here is maybe about 2. So that's why I'm drawing about a 2 of the y. Here, it's about 45 degrees, so that's about 1, right? That's a 45-degree tangent line, so that slope is about 1. That's why at that x-coordinate, my y is 1. Now here, where it's a max, it is 0. So at that x-coordinate, our y prime should be 0. So that's why the y-coordinate is 0 there. So now we're going negative, negative, down, 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 down. Now right around here, it's an inflection point. So see, it starts coming up. It's going down, down, down. And then here, it's an inflection point. It's coming back up. It's coming back up. It's coming back up. It's coming to 0 right there. And then it's increasing, increasing, increasing forever after. Okay? So that's kind of what we're doing here. So the green, again, is f prime. We were increasing, 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 but we're getting less and less positive. You see that number? It was like, that slope right there is like 20. And then it's getting less and less and less positive. It's still positive. Less and less positive, it's going to 0. Now it's getting negative, that slope, because it's decreasing. All right, let's move on. So if I have all this information, then let's determine where f is increasing or decreasing. So we know f is increasing where f prime is greater than 0. We know f is decreasing where f prime is less than 0. Here is information about f prime. Let's put it on a number line. I love my number lines. So we know f prime is 0 equals 0, 2, and 5. So 0, 2, and 5 are going to go on my number line. F prime is greater than 0 between 0 and 2, positive. Less than 0 when it's less than 0, so negative. And then it's negative from 2 to 5. And then it's negative again from 5 on. Okay, so it's going to go negative, positive, negative, negative. Let's go ahead and just do our f double prime number line while we are at it. We can see that it is positive, less than 1. So less than 1, it was positive. Between 4 and 5, it's also positive. 4 and 5, it's also positive. It is negative between 1 and 4, and then after 5. All right, there we go. So f is increasing when f prime is greater than 0, and that's going to be between 0 and 2. F is decreasing when f prime is less than 0. That's going to be before 0, negative infinity to 0. And then again from 2 to 5, 5 to infinity. I like to split it up because it's actually 0 at 5. Part B, when is f concave up? F is concave up when f double prime is greater than 0. That is happening from negative infinity to 1. And then again from 4 to 5. F is concave down when f double prime is less than 0. And that's just from 1 to 4 and 5 on. Now, I could ask some extension questions, such as where are my maxes and my mins? And that's would be here. I have f is a min because f prime changes from negative to positive. And then here I have a max because f prime is going from positive to negative, right? And then there's neither here. So I only have one min and one max on this one. And then if I wanted inflection points, I could say that I have inflection points wherever f double prime changes sign. So f has inflection points at x equals 1, 4, and 5 because f double prime changes sign. So remember, we're looking for sign changes and not just that it equals 0 for the min, the max, and for the inflection points on f double prime. Okay, so on this worksheet, we needed to identify which one's f, which one's f prime, and which one's f double prime. On this first one, the strategy that I'm going to use is that I know that, to take a derivative, if I have y equals x to the n power, then the derivative is n x to the n minus 1 power, and the second derivative would be, n times n minus 1, x to the n minus 2 power. Pretty much I'm subtracting 1 from the power every time I take another derivative. And so in this one, you can kind of think of it as how many turning points. Like you can see this one looks kind of like a third degree, and this one looks like a second degree, and this one looks like a first degree. And so that's almost the giveaway for this one right here. And we're going to check it, but we're going to start with saying, I think that this is F prime, and this is F double prime. Now let's check it. You see that it was increasing 0 and then increasing again. So that means that the derivative should be positive 0 and then positive again, which positive, right? It's positive there, 0 around there, and then it's positive again. And now if you look at this guy and you make that your function, then we see that this was decreasing 0, then increasing. And so its derivative should be going from negative to positive, and that's happening, right? So that one works. That looks good. Now in my next one, I'm going to kind of take a similar hint of being like, all right, it's subtracting 1. Maybe things are switching up. I'm thinking that this one is my odd guy out, right? So it's probably F prime because I want to like flip-flop between them. So let's start with this being F prime and let's see what its derivative would be. I think that going to its derivative is a little bit easier than the other way around. And so you can see this one is decreasing the entire time. If it is decreasing the entire time, it's getting closer to 0 at the end, right? It's flattening out to 0 at this end, but it's decreasing the whole time, meaning its derivative must be negative the whole time. Which graph is negative the whole time and getting close to 0? Only this one. So that must be F double prime. So now let's start with this one as our F and let's see if it works out. This one was increasing the entire time. So its derivative must be positive the entire time. It is flattening out to 0, not flattening out as much as this one flattened, but it's flattening out. And so is that happening? It is increasing, getting less increasing. So its derivative is positive, getting less positive. See, F is increasing the entire time. So F prime must be positive the entire time. It is. So that works out. In this next one, I'm going to use that same strategy I used above. I see that this one looks like the oddball out. And so I'm going to start with that one as probably being my F prime. And what do I notice about this F prime? I notice that it is increasing the entire time. It is increasing, getting less increasing, then getting more increasing again. So it should be positive the entire time. It's getting less positive and then it's getting more positive again. Which one checks out? This one is the only one that is positive the entire time. It is positive, less positive, and then more positive again. That says exactly what I was going for. So let's go back and just make sure that this could actually be F. Could this actually be F? This one is decreasing, so it should be negative. Yep, it's negative. And then it's increasing. Yep, positive. And the min is right around there, so it should be a 0. Yep, it's a 0. So that checks out. Now in these, I'm really going to pay a lot of attention to the zeros and make connections between maxes and mins. So let's just start with this solid lined one. So you can see there's a max here. So if there's a max, then its derivative should be changing from positive to negative, right? A max positive to negative. The only one that's changing from positive to negative at that point is this one right here. So I'm going to call this F. I'm not sure that's true yet, but I'm just going to call that F for a second. Then this guy is its only possible derivative. Let's make sure it's its derivative the whole time. I have a minimum here. Yep, that one's changing from negative to positive. I have a maximum here. Yep, that's changing from positive to negative. Yep. So that relationship does work out. Now I'm going to look at this one. I'm going to just make it blue for a second. And see, could the dotted line be its derivative? So here it is a minimum. Oh no, that's not a 0. So that's impossible. It can't be that relationship. So let's just try moving everything down for a second. Let's make this F prime, then this would be F double prime. So could the dotted line be F? Let's take a look at that. So if the dotted line is F, then it has a maximum here. And we're saying, could this one, so let me just make it red. Could the red one be its derivative? Maximum, changing from positive to negative. Yep. Minimum, changing from negative to positive. Yep. Maximum, changing from positive to negative. Yep. Minimum. Yep. Looks like it's a go. So we are going to have this dotted one be F. The red one that I drew is F prime, and the blue one that I drew is F double prime. So now let's go to the next one. And I have a dead giveaway of which one's F here. You see how all of these graphs have multiple mins and maxes? Well, this guy up here is always positive. So could it be anybody's derivative? No, it could not be anybody's derivative. If it was somebody's derivative, then it would have to have zeros, but it doesn't have any zeros. You see that? So like this guy's maximum would have to be a 0 on f prime. And no, actually this one, it's a max here and nobody has a 0 there. So that's a dead giveaway that's f double prime. And this one's probably f. Let's make it all work. So if this is f, then we have a max here. So which one has a 0? This one right here. Let's make it blue for a second. So that checks out. And then we have a minimum here. Yep, it's a 0. And then we have a maximum here. Yep, it's a 0. And, it was decreasing. So it was negative that whole time. It was increasing. It's positive that whole time. It was decreasing. Yes. And now let's look at f prime. And we had a minimum here. And look at that. We have a maximum here, and look at that. We have a minimum here, and look at that. It all works out. F prime, f double prime. So remember, I started with this one because I was like, no, you know what? That one doesn't have any zeros, that graph, so it can't be anybody's derivative because there's too many maxes and mins going on this one. All right, this last one, start with the solid one. So I see that I have a maximum around there. So because I have a maximum in this one, its derivative must have a 0 around there. So I'm thinking this is probably f and this is probably f prime. If this is f prime, then is there a minimum? It looks like there's a minimum around there. This is not my favorite graph, but again, just look at the zeros and the mins and the maxes and you should get that relationship. So I would like you to do this. I would like you to summarize what I have done in this section, how you determine f prime, and f double prime when given all three. So some of the things you might note are like the flip-flopping that I talked about, the relationship between the maxes and mins and the zeros that I talked about. So just clarify 3 things that you really learned in this video on this slide in your notes. Finally, I just wanted to end with one that we've seen so many times this year, y equals the absolute value of x, but this time I want you to sketch the graph of its derivative. So we know that y equals the absolute value of x looks like this and this because y equals the absolute value of x is defined as the opposite of x for any values less than 0, and itself, y equals x, for any values greater than or equal to 0, right? So y prime, if I look at this piecewise, is just going to be the derivative of negative x is negative 1 for values less than 0 and 1 for values greater than 0 because the slope is literally negative 1 and then it jumps to positive 1. So we've not graphed it before. I just wanted to graph it. So it was negative 1 the whole time and then it jumps up to positive 1 and it is not differentiable at 0. So I should keep open circles on both of those. We cannot take the derivative right here at the point 0. It's not differentiable. And so this graph here, y prime, is not continuous, which was how we were proving differentiability when we were doing it algebraically. Again, I just want you to see it graphically so that you can make the connection. And that's it for this lesson. I hope it helped. Bye.